Okay, hello everyone. In our last class, we have been discussed in detail about calculation of system of matrix for thick lengths. In detail, we have been discussed. Okay, and also we evaluated the cardinal points of thick lengths with a numerical. We discussed a numerical. I suggest that you just remember these equations, which help to find out the cardinal points of the of a thick length. And this matrix represents the system of matrix of thick lengths. In detail we have been discussed, and this numerical also we discussed in detail. Okay, in this class we are going to discuss calculation of system of matrix for a thin length. Okay, here it starts. We know from equation number 1, this is your equation number 1, that is your system of matrix of a thick length. This one same I written over here once again. Okay, here this SM thick lengths, system of matrix of thick lengths is this one, what we evaluated in our last class. This is your equation number 1. Now consider a thin length. For a thin length, this thickness will be approximately equal to 0. So instead of t, what we have to substitute? 0. Here 0, here 0. Then system of matrix for thin lengths will be this one. This value also 0. This term also 0. So this first term will be 1 and this value will be 0, and here this term will be cancelled out, this term will be 0, and we can get p1 minus p2, and this term will be 1 minus 0. Okay, and we know that p1 equal to mu minus 1 by r1, and for second refracting surface the power is your 1 minus mu by r2. Just substitute over here. Let this is your equation number 2, and this equation number 2 represents in general system of matrix of thin lengths. Okay, but in general the system of matrix of any optical system is represented by what? Is represented by A, B, C, D. Okay, and in our previous class already we discussed, when mu I equal to mu O, that means input side refractive index will be equal to output side refractive index, then f1 equal to 1 by C, f2 will be equal to minus 1 by C, and magnitude of these f1 and f2 values will be are the same. That means first and second focal length of the lens or the optical system will be same. Okay, if mu I equal to mu O, and here f1 represents the location of first focal point from principal plane, and this is your second focal point from the principal point. Already we discussed in our previous class. Here this one f1, obviously it will be minus, so f1 represents equation number 10 and 15, first and second focal points from first and second principal points, and this value, if mu y equal to mu O, this value will be 1 by C, and this value f2 will be minus 1 by C. Okay, now here, okay, and corresponding magnitudes will be same. Hence, by comparing above two matrices, we can write, you just compare this matrix, general system of matrix, and this one. Here C value is nothing but this much, and here we found f2 is nothing but minus 1 by C. So here f2 equal to minus 1 by C, so that implies C equal to minus 1 by f2, right? Minus 1 by f2 will be equal to C. Okay, so same thing I have been written over here, minus 1 by f2 is equal to C. C means this value. As such I written here minus mu minus 1 by r1 minus 1 minus mu by r2. You just remember this one. Okay, so that implies here same equation I written over here, so that implies 1 by f2 will be equal to plus mu minus 1 by r1 plus 1 minus mu by r2. That implies 1 by f2 will be equal to mu minus 1 by r1. Here, instead of 1 minus mu, we can write mu minus 1. Here, plus will be minus of mu minus 1 by r2. Right? That implies 1 by f2 will be written as mu minus 1 whole into 1 by r1 minus 1 by r2. Here, r1 is the radius of curvature of first surface, and r2 is the radius of curvature of the second surface. Okay, this is the first surface radius of curvature, this is the first surface, this is the second surface, this is the thick lens. Considering thin lens is this one. Okay, we know mu2 by mu1 equal to mu. Why? Here we consider that this side and this side refracting index is your 1. Why? This side and this side we consider as vacuum or air medium. So here mu1, here also mu1, refractive index will be 1. Okay, so mu2 by mu1 we considered mu, because mu1 value is your 1. So here instead of mu, if we are going to write in general format, then we can write 1 by f2 will be equal to, instead of mu we can write mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. So this expression represents the reciprocal of focal length of a thin lens when left side and right side of this optical system or thin lens is belongs to air medium. If this side and this side is not belongs to air medium and having the refractive index mu1, then reciprocal of focal length of this thin lens will be written this one. So this is in general expression from which we can evaluate the focal length. Just reciprocal of this one we can found f2. 1 by f2 is this one. Reciprocal of this one we can get f2. Okay. Okay, the above equation represents the general expression of reciprocal of focal length of a thin lens. Right. From the above discussion, the system of matrix of thin lens can be written as here. Instead of C, what we can write here? Instead of C, this one, this term can be written as minus 1 by f2. Same thing I have been written over here. Here 1 1 0. This will be written as 1 by minus 1 by f2 1. Okay, here minus 1 by f2 1. Right. So here f2 is nothing but second focal length. That means this side generally we have the first focal point f1, and the corresponding focal length from focal point to principal point is your f1, but this side is your f2. Okay, so in general f2 is written as simply f. Right. So here in general it is written as 1 0 minus 1 by f1. Okay, here because f1 equal to minus f2, so instead of if I'm going to write the f1 instead of f2, if I'm going to write f1, then this expression will be like this: 1 0 1 by f, not minus, plus 1 by f1. So in general it will be written as 1 0 minus 1 by f1. Okay, and in the general system of matrix is your A B C D. If I'm going to compare this one with this one, then A value is your 1, B value 0, C value minus 1 by f, D value is your 1. Right. Now we are going to move our next slide. Yes, before we are going to move our next slide, I suggest that you just remember this expression, this matrix. This is your system matrix of thin lens. 1 0 minus 1 by f1. This f represents the focal length of the thin lens. Okay. Also I suggest that you should remember this equation also, this equation number 2. This equation number 2 represents the system matrix of thin lens in mu and r format. 1 0 mu minus 1 by r1 minus is there minus 1 minus mu by r2. R1 r2 are the radius of curvatures of two surfaces. You just remember this matrix, because this matrix will be help you to solve the different numerical. Okay, now we are going to move our next slide. Okay, here we are going to calculate the location of cardinal points of thin lens. Okay, in equation number 2 we found this one just now. I told to you that you have to remember this one. System of matrix of thin lengths is your 1 0 minus mu minus 1 by r1 minus 1 minus mu by r2 and 1. In general, system of matrix is your A, B, C, D. Comparing these two matrices, we can found A value is your 1, B value is your 0, C value is this much, D value is your 1. Okay. Okay. And from last class, we found for mu I equal to mu O, equation number 5 and 14 represents what? First represents the location of first and second focal points from input and output planes. The expressions are x1 is your d by c, x2 is your minus a by c. So by substituting these values here, d value 1 by c we can found x1, a by c we can found x2, r1 r2, that is your 16 and 17 equations represents the location of first and second principal points from input and output planes. Z1 and Z2, here equation number 20 and 22 represents the first and second location of first and second nodal points. Here F1 and F2 represents the location of first and second focal points from first and second principal points, and the corresponding magnitude will be the focal lengths. Okay, so here you can see that d value is your 1. So if I am going to substitute over here d equal to 1, this z1 will be 0, z1 will 0, value will be 0, z2 a value is your 1, so also z2 equal to 0. Like that, r1 value, if I am going to put d equal to 1 and a equal to 1, r1 and r2 both we can found 0. So here what we concluded, for a thin length, principal points and nodal points are absent. We cannot found principal and nodal points for a thin length, but for a thick length we can found we can found the principal points and nodal points, but these 4 points are absent in your thin lengths. Okay, so this is all about the system of matrix of thin lengths and location of cardinal points of thin lengths. So here I'm going to stop this class. Here, before I'm going to stop this class, I want to share a important information with you, that we know that a system of matrix will be acceptable if the determinant will be 1. Here you can see the determinant of this thick length is your 1. Here 1 into 1 1, and this is 0. So the determinant of this matrix is your 1. Now consider the thick length, whatever we have been discussed in our last class. This is the system of matrix of the thick length. You just do rough, the determinant of this matrix, this into this minus this this term into this one, you just do rough, you can found the determinant of this matrix also equal to 1. Okay, so here I'm going to stop this class. In our next class we are going to discuss finding the equivalent focal length, capital EQ U I written over here, and cardinal points of two thin lenses separated by a distance with numerical. Here, if we are going to consider this situation, two thin lenses separated by a distance t, then what will be its equivalent focal length and corresponding cardinal points. Here you can see this is called as your system of matrix, combination of two lenses. Okay, next class we are going to discuss this topic. Thank you. So thank you so much for watching this video. Thank you.